All right, everyone. Check for understanding, lesson 9.3. This was the Skittles lesson, Taste the Rainbow. The question is, who feels job stress? So let's dig right in. The first thing we're looking for is the parameter, and it says a news report claims, well, that's important, claims that 75% of restaurant employees, they feel that work stress has a negative impact on their personal lives. So that is the parameter that we're measuring. We are measuring, and I already wrote it down just to save a little time. That is the percent or proportion of their employees who feel that work stress negatively impacts their personal lives. And the claim is that 75% of their employees think that. Okay, so that leads right into your null hypothesis. Hypotheses is plural, so that means the null and the alternative. Those look pretty similar. Fig, H null, H A. So the null is that P is 75%. All right, let's read on here. The managers, they wonder if the claim is valid for their employees. A random sample of 100. Let's just use a different color. There's your sample size. Finds that 68 answer yes when they were asked this question about feeling stress. Does work stress, when they were asked this question, right? Does work stress have a negative impact on your personal life? The question is, do these data give convincing evidence at the alpha of 0.10? Let's highlight that. Alpha is 0.10 this time. Convincing evidence that the proportion of employees in this chain who would say yes differs from 0.75. So the key here is it says differs. We're going to get into this a little bit, which is kind of a hint that we are going to do a two-sided test. It didn't say less than 0.75. It didn't say greater than 0.75. Just say, what is it different? So that is our alternative. That P does not equal 0.75. Okay. The statistic comes from what's orange up here. P hat is our statistic, 68 out of 100, or 0.68. The significance level, that's alpha, so 10%. And the evidence for the alternative is simply that our P hat does not equal P. 0.68 does not equal 0.75. So it's just kind of like very basic information that we have from the start. All right, the name of the procedure, remember you always have to name it, will be a one sample z-test, because proportion tests are always z-tests, for P, okay, for the proportion. Is it random? Did it say random up there? Oh, it sure did. It said it right here. Random, right? So it was stated. Large counts, we use the sample size, and we use P, not P hat. That's pretty easy math there. That's 75 successes. That's greater than 10. Then 100 times 0.25 would be 25. Remember, I've said this a few times, but I'll say it again. These two numbers always add up to 100, or more generally, they always add up to the sample size. Remember to tell me what this means. It means the data is approximately normal, or you can say approx if you'd rather. Then number 3, are they independent? You could say generally that one employee's feelings about this are independent of another employee's. Or if you do the math, you do 10 times n. 10 times 100 has to be less than the population. The population in this case would be of all employees. Did they tell us how large this company was? Do we know if there's 1,000 employees? I don't know, right? So you would maybe say, I'm not sure. So 10 times 100 is 1,000, right? Is 1,000 less than the population? Maybe put a question mark. You could say proceed with caution. I don't know. Okay, what is the mean? Remember, if we take a whole bunch of samples, the average p hat will equal p, which is 75%. We are always operating under the assumption that the null hypothesis is true. So if this is true, we will take a whole bunch of samples and they will be centered at 0.75. Some will be bigger, some will be smaller, but they will be centered right here. Standard deviation formula is the square root of 0.75, 1 minus 0.75 over sample size. Just take your time when you do that. And that is, I don't think I calculated that. Well, let's take my calculator out. Square root 0.75 times 0.25 divided by 100. So we have about a standard deviation of 4.3%. Okay. So here's my picture. I like to sketch the graph. You guys know that by now. So it should be centered here. Where is my sample? Is my sample above or below the mean? My sample was 68%, so it's down here somewhere. 0.68. What I need to find is what's the probability of a sample like this or more extreme. So I need to get the z-score. The general formula is this, which is also up higher in your quick notes. Here's the specific formula for that we'll use, okay? Let me make room for work. So that would be p hat is 68%, p is 75%, and then I'm dividing by the standard deviation, which I just found as 0.043. That will give me the z-score, and I've done this one ahead of time. That is negative 1.62. Okay, that is the z-score for this mark right here. So that is the vocab, that is the test statistic. Okay, to find the p-value, we need to look it up in the table, the table A, negative 1.62. Negative 1.662, so 0.0526. So my p-value, hold on a minute, that means this area is 0.0562. However, this is where we need to slow down and think here. Whenever we are doing a two-sided test, we are not only checking for the probability that we get a sample like this sample happens to be less than, but what about if the sample was also greater than an equal amount? So we have to kind of mirror this over here and think the z-score here was negative 1.62. What about a positive z-score of 1.62? This red shaded area would be a reflection of the one on the left. That would also be 0.5062. So really, to get a sample like this, a sample this far away from the mean could be either direction from the mean. It just has to be different than the mean. So in the quick notes, do you see here, it says when you do your p-value of a two-sided test, you double the area that table A gives you. Because table A will always only give you one side. It will never give you both sides. So all that is to say, my p-value is twice what the table said. 2 times 0.0562, which is a little bit more intriguing. That's really, really close to alpha. It's 0.1060. Let me show you this on the calculator as well. It might help. I've got this calculator. So stat tests. We're doing number 5. It's a 1 proportion z-test. Number 5. I already put in the p, 0.75. The 68 was the number of employees that said they are stressed. And 100 is the sample size. And so there it is. You can see right there it has the green shading on both sides because I have, on the bottom, I have a not equal to test selected. If I click on the less than button, you can see now it's only doing the left side, and it's got that p-value that the table A gives you. Has the correct z-score. So if it was a one-sided test, that would be p. But when I click to two-sided, again, you have to look at both sides because it's just as likely to be this far below the mean as it is to be this far above the mean. You'll kind of notice when we do two-sided tests, it's very common for alpha to be bigger because to take into account that it's two-sided. So maybe you raised your eyebrows right away. You're like, oh, this isn't 0.05 like it usually is. And there's kind of a reason for that. Okay. Conclusion. With p, this is really picky, but with p being greater than alpha by just a little, right? 0.1060 is greater than 0.10, but not by much. We will fail to reject the null hypothesis. The evidence suggests that the true proportion could in reality be p equals 0.75. You could also say it another way. Yeah, well, there's just not enough information to reject the null. It's really close, folks, but there's not enough. Man, I can't spell it. That. And then I missed the word. The true proportion. Okay. Or maybe here's a better way to say this. We do not have, the question is maybe this, do we have significant evidence here or not? We do not have significant evidence that the proportion, these get wordy, folks, of employees who feel stressed. I'll kind of shorten up that stress part. I know it's a little more complicated than that. We do not have significant evidence that the proportion of employees who feel stressed is different than the claim, or different than the news report claim, different than the claim of 75%. That's probably, that red conclusion is a little bit better than this blue sentence right here. They would both get the job done, but I like the red one better. All right. That's all for now.